question 7 on this test, the question that has the most parts and is worth the most points. You definitely want to slow down and take your time on this question. Make sure you're putting in everything right. Make sure you're using math type right with the comma separated events that you're putting in. You absolutely want to do this sample test problem, try it in WebAssign, make sure your answers are in the right format that they're going to accept, because you know you only have one attempt when it comes to the real final. So here they tell me that there's 5 events in the sample space labeled E1, E2, E3, E4, and E5. We then are told which of those fit into each of A, B, and C. A includes E3 and E5, B includes E1, E2, E3, and E4, and C includes E4 and E5. We then know what the probability of each of these are. Really all we're doing is taking the number of events, dividing by the number of events in the sample space. So 2 divided by 5 is where this 0.4 is coming from. 4 divided by 5 is where this 0.8 is coming from. And 2 divided by 5 is where this 0.4 is coming from. When we talk about a complement, it's everything not included in that set. So when we say a complement, we have E3 and E5 in A. That means the things we don't have in A are E1, E2, and E4. These are the 3 events that are missing from A, so these are the 3 events in A complement. The probability of A complement, there's 2 ways I can see this. Either it's 1 minus the probability of A, 1 minus 0.4 would give me 0.6, or I can see it as the 3 events in A complement out of the total sample space. 3 divided by 5 would also give me 0.6. For A intersect B, we only count events that are in both A and B. So A is E3 and E5, B is E1, 2, 3, and 4. The only events that are in both are E3. So E3 is the only thing I'm going to list here. The probability is the 1 event that occurred out of the 5 possibilities. And that's how I get 0.2. For B intersect C, same idea. I look at the 2 sets. I say, what's the overlap? Well, E4 is the only thing that occurs in both. So E4 is the event that's in B intersect C. Again, it's just 1 out of 5 total events in the sample space. That's why its probability is 0.2. For A union B, when it has this symbol, it means it includes anything in both or either. So I start with A and say E3 and E5 count. Then I add in things from B, so I add in E1 and E2. I already counted E3, now I add in E4. That means we end up with everything in the sample space. E1, E2, E3, E4, and E5. Since we have everything in the sample space, we have 5 of the possibilities out of 5. That's why it occurs with probability 1. When we look at the conditional, B given C, the most important part is understanding that after the conditional line is where we start. So we know C has already happened. It's either event 4 or event 5 that's happened. Those are the only 2 possibilities. Probability of B happening when C already happened, the only event that counts is event 4. If we know either event 4 or event 5 happened, B has only event 4 in it. So here, event 4 is the event that counts. In this case, it's only 1 event that counts, but we've changed our denominator. Instead of being out of the entire sample space, E1 through 5, it's only out of what's happening in C. So there's only 2 events that it would be out of. That's why this occurs with probability 0.5. When I do A given B, in this case, B is after the given line, so I'm starting out with the assumption that one of these 4 events happened. Of these 4 events, the only one that's also in A is E3. So the only thing that counts here is E3. That's 1 event that counts, but in this case, instead of being out of 2 like it was when it was conditioned on C, it's out of 4 because it's conditioned on B. So after the given line is B, there's 4 events in B. That's my denominator. When I do this division, I get 0.25 as my probability. G asked me to find the probability of A union B union C. Really, this union C is completely unnecessary. We saw above that when we did A union B, that included everything. So even though we're saying C is also included with E4 and E5, we already had that above. We still have all 5 possibilities if we have this union. If, for instance, we didn't have E5 in A, then by adding in the union C, E5 would come in and give us all 5. But basically that union means anything in here, or anything that occurs in both. So in this case, I'd want to list all the events, E1, E2, E3, E4, E5. Those 5 events out of 5 total things that can happen means it occurs with probability 1. Last one in this section asks me for A intersect B complement. The good news is I already did A intersect B. A intersect B was up here as E3. If I want to do its complement, I basically just list everything in the sample space that isn't in this intersection event. So the only thing that I'm not going to list is E3. I am going to list everything else, E1, 2, 4, and 5. So E1, E2, E4, and E5. That means there's 4 total events that fit out of 5. That's why it occurs with probability 0.8. The other way I could have gotten to that probability, I could have said, well, here I saw that A intersect B occurs with probability 0.2. If I do 1 minus that 0.2, that would also allow me to arrive at 0.8.